Hello everyone, I am Geeta, Assistant Professor, Department of Mathematics, SNS College of Engineering. In this session, we are going to discuss about problems on randomized block design. Here, a tea company appoints 4 salesmen A, B, C, D and they observe the sales in 3 seasons and the data is given below. Here they have given the season summer, winter and monsoon and 4 salesmen are appointed here A, B, C, D. So, sales and the data is given as 36, 36, 21, 35, 28, 29, 31, 32, 26, 28, 29, 29. Now, we are going to analyze, do the salesman significantly in performance and is there any significant difference between the seasons? Okay, so here we are going to check row and the column wise. That means is there any significant difference between sales months and the seasons as well as. So which is coming under randomized block design. Here first we frame page node. That means there is no significant difference between rows and the columns. That means the seasons and the salesmen. After that we frame alternative hypothesis stage 1. This means that there is a significant difference between rows and columns. That means salesman and seasons. Now given data are in double digit. First of all, we convert this into single digit. Why we are converting this means because simplify the calculation. So we subtract the common element in each and every element here. Here we take 30 as the common element and 30 is subtracted. Each and every element here is subtracted by 30. For example, 36 minus 30 we get 6 and 28 minus 30 we get minus 2. So minus 2 is here. 26 minus 30 is equal to minus 4. Likewise, each and every element is subtracted by 30. After that, the data will be displayed here. And now we are supposed to find the row total and the column total. Here, the row total is 8, 0 and minus 8. And likewise, we find the column total. That is 0, 3, minus 9, 6. After that, we have to find x1 square, x2 square, x3 square, x4 square. So, given x1 is 6 minus 2 minus 4. Squaring this value, we get 36, 4, 16. Likewise, we square x2, likewise we find x2 square, x3 square and the x4 square. After finding this value, we add this value, which is nothing but summation of x1 square, this is nothing but summation of x2 square, this is nothing but summation of x3 square, this one is summation of x4 square. So, now first we find n. N is equal to 12 here. N is nothing but here number of observation. Here they have given 12 data, so n is equal to 12 here. After that we find t value. T is total of observation. So adding this total we get 0. Here the total value is equal to 0. After that we find t square by n. This is nothing but correction factor. We say which value is equal to 0 here. Next we are supposed to find total sum of square. Its formula is summation of x1 square plus summation of x2 square plus summation of x3 square plus summation of x4 square minus t square by n. Here the x1 square value is 56, then plus 41 plus 83 plus 30 minus t square by n, we get 210 is the TSS value. Next we find sum of square between column, that is take it as SSC, that is equal to summation of x1 the whole square by n1 plus summation of x2 the whole square by n1 etc. minus t square by n. Here n1 represents the number of elements in each column. Okay, so here sum of x1 is 0, taking square divided by 1, 2, 3. So in column wise we have 3 elements divided by 3, we get sum of x1 the whole square by n1. Likewise we square by n, which value is equal to 42. Next, we need to find sum of square between rows, which formula is summation of y to the whole square by n plus summation of y to the whole square by n to etc. minus t square by n. Here the sum of y1 represents the row total. 6 plus 6 minus 9 plus 5, which is equal to 80. So 80 the whole 8 the whole square divided by n2 represent the number of elements in each row. So in each row we are having 1, 2, 3, 4 elements. So divided by 4 plus next sum of y to the whole square by n2. Likewise we find the remaining values and it is subtracted by the fraction factor, which value is equal to 32 here. Next we need to find the sum of squares in the error. So which value is equal to TSS minus SSC minus SSR. After finding this value, we need to tabulate these values here. So here are the source of variations between column, between row and error. Next column represents the sum of squares, that is SSC, SSR, SSE. So here we substitute these values here and its corresponding degrees of freedom in each and is calculating corresponding degrees of freedom. So in SSC column its degrees of freedom is column minus 1, that is equal to 3 here, and in row wise in SSR its degrees of freedom is row minus 1, that is equal to 3 here, and next we calculate SSC degrees of freedom, that is n minus c minus r plus 1, which value is equal to 6. After that we find its mean square value, which will be calculated by the formula SSC by degrees of freedom, SSR by corresponding degrees of freedom, SSE divided by its corresponding degrees of freedom. After finding mean square value, we need to find the F ratio. So F ratio in column wise, which value is equal to MSE divided by MSE, because in here numerator must be greater than the denominator. Using the logic, we calculate the F ratio value in column wise, which value is equal to 1.69. Next, parallelly we need to calculate the corresponding table value for the corresponding degrees of freedom, which value is equal to 8.94 here. So similarly we find the F ratio in row wise, which value is equal to MSC divided by MSR, that is equal to 1.41. Corresponding F ratio table value is equal to 19.35. So comparing calculated and the row value here, calculated value both row and column wise is less than the table value. So here we accept the H0. Thank you.